Good morning, everyone, and welcome to today's webinar, The Rise of the IoT Platforms. My name is Sandra Muller. I am the marketing partner at Momenta Partners, and I will be the facilitator for today's webinar. This event is brought to you by IoT Analytics, Davra Networks, and Momenta Partners. This is the first in a series of IoT webinars specifically created to cultivate the connected industry. Before we get started, I'd like to go over a few items so you know how to participate in today's event. You should see something that looks like this on your own computer desk in the upper right corner. To the left is the Go to Webinar viewer, through which you see the presentation, and to the right is the Go to Webinar control panel where you can ask questions. You will have the opportunity to submit text questions to today's presenter by typing your questions into the question pane of the control panel. You may send in your questions at any time during the presentation. We will collect these and address them during the Q&A session at the end of today's presentation. At this point, I would like to introduce our feature speaker so we can get into our content. Padraig Scully is VP of Market Research at IoT Analytics. Padraig leads the market research team at IoT Analytics. He has extensive experience in telecommunication and technology research. Paul Glynn, CEO of Davra Networks. Paul is responsible for managing and building partner relationships and for strategic customer development at Davra Networks. And our third speaker will be Kevin Holbrook, venture partner at Momenta Partners. Kevin helps companies maximize value from their IoT solution. He previously led partner technology strategy at ThingWorx PTC and Axeda. This is our agenda for today. IoT Analytics will be starting off, highlighting their findings on the IoT platform market, general observation, and interesting facts. Then Kevin Holbrook from Momenta Partners will be discussing the current challenges IoT platform providers are facing. This will be followed by Paul Glynn from Davra Networks, who will be showcasing a demo of their IoT platform. And after that, Kevin Holbrook will be summarizing what has been discussed and share future trends. At the end, during our Q&A session, we will be answering 3 to 5 questions. With this, I'd like to hand it over to Padraig Scully from IoT Analytics.
Padraig Scully from VP Marketing Research will be presenting soon.
Hi, thanks, Tom. So, hello, everyone. My name is Padraig Scully, and I lead the market research team here at IoT Analytics. In part 1, I want to introduce the technical aspects of IoT platforms and highlight some key market insights from our latest report. So, in Q4 last year, we sat down to write a new market report on the Internet of Things. We wanted to choose a topic of major strategic importance for many different companies. So we looked at things like security, analytics, and applications in IoT, but one topic stood out as a basis for all IoT solution development, and that was IoT platforms. Our main goals were to firstly demystify the ambiguous term, detail the actual components that make up an IoT platform, and then understand how big the market is, which segments and regions are accelerating the growth, who are the leading companies, and analyze some top trends shaping the market. So following deep interactions with a number of key IoT platform providers, we put together a comprehensive industry report on the current state of the IoT platform market and its potential to 2021. So many industry experts say IoT will be the most influential and most disruptive technology of our time, with estimates at the top end putting IoT as an aggregated 11 trillion business opportunity over the next 10 to 15 years. And this is going to equal about 11% of the world economy. So naturally enough, business leaders are all taking note of the hype around IoT and the potential that offers in their specific industries and segments. IoT platforms are emerging as an integral part and the principal software interface that brings everything together in the overall IoT infrastructure. However, it can be quite a confusing term. So what is an IoT platform really? Well, at a basic level, it connects the real and virtual worlds to enable communication between objects, people, and systems. Now, many companies say they offer an IoT platform, but in reality, not every platform is an IoT platform. And a closer comparison reveals vast differences. So for a newcomer, it can be quite difficult to understand whether the term refers to a complete and mature IoT cloud platform, or whether the term has been stretched to describe just an element which makes up only a part of the IoT platform. When we talk about an IoT platform, we generally refer to an IoT application enablement platform, or AEP. So I'll cover this on the next slide. There are 4 other major types of platforms that make up part of an IoT platform, but not considered a full IoT platform by itself. So the first one is connectivity machine-to-machine platforms, which focus mainly on the connectivity of IoT devices via telecommunication networks, for example with SIM cards, but rarely on the processing and enrichment of different sets of sensor data. So an example of a connectivity platform is Sierra Wireless AirVantage. Number 2, infrastructure as a service backends. So these provide hosting space and processing power for applications and services. These backends used to be optimized for desktop and mobile applications, but now IoT is also in focus. So IBM Bluemix is an example of a platform running on infrastructure as a service backend. Number 3 is hardware-specific software platforms. Excuse me. So from companies that sell connected devices, they've built their own proprietary software backend. And they like to refer to this as an IoT platform. However, since it's not open to anybody else, it's debatable whether one should still call it an IoT platform. So Google's Nest platform is a good example. Number 4, consumer enterprise software extensions. So existing enterprise software packages and operating systems like Microsoft Windows 10, they're increasingly allowing the integration of IoT devices. So currently these extensions alone are not often advanced enough to classify as a full IoT platform that can process, say, large amounts of real-time sensor data. Another confusing aspect is that companies are starting to build out their IoT capabilities and combine different services. So IBM, for example, is combining what's an IoT application enablement platform with its Bluemix backend. Or Microsoft is integrating Windows 10 devices with the Azure IoT suite. So we like to categorize the IoT platform into 8 distinct components. Number 1 is the connectivity and normalization. So this brings different protocols and different data formats into one software interface, ensuring accurate data streaming and interaction with all devices. Number 2 is device management. This ensures the connected things are working properly, seamlessly running patches and updates for software and applications running on the device. Number 3 is the database. So this enables scalable storage of device data that brings the requirements for hybrid cloud-based databases to a new level in terms of data volume, data variety, velocity, and veracity. Number 4 is processing and action management, and that brings data essentially to life with rule-based event action triggers enabling execution of smart actions based on specific sensor data. Number 5 is analytics, and here we perform a range of complex analysis from basic data clustering to deep machine learning to predictive analytics, and this essentially extracts the most value out of the IoT data stream. Visualization enables us to see the patterns and observe trends from visualization dashboards where the data is portrayed through various graphs or maps or charts, even 2D or 3D models sometimes. Number 7 is additional tools. So these allow IoT developers to prototype and test IoT use cases, creating a platform ecosystem apps for visualizing, managing, or controlling your connected devices. Number 8 is external interfaces. So these allow us to integrate with third-party systems and the rest of the wider IoT ecosystem via built-in APIs or SDKs and gateways. It's worth noting that built-in security is essential for all of these components. So the platform architecture has to be holistically designed so the threat of cyber attacks is minimized at every level and across the stack. So examples would include PTC's ThingWorx platform, LogMeIn's Ively platform, and Davra Networks' Rubin platform, which you'll see later in the demo. Okay, so now we know what we mean by an IoT platform. So how big is the market? So our database currently shows more than 360 platform providers, and this number is continuing to grow. Why? Well, even though early estimates of 50 billion devices by 2020 have now been scaled back to between 25 and 30 billion, this is still a significantly large number of connections. So platform providers see the $1 trillion projections being made and know even a small percentage of this is a billion-dollar opportunity. So, however, to date, the reality is that many of these platforms are only connecting hundreds or thousands of devices and have made no or little revenue. So our estimates reveal the worldwide IoT platforms market was just under 300 million in 2015. And with a compound annual growth rate of 33%, we expect the market to become a $1 billion opportunity 3 years from now. This may seem conservative, but the overall year-on-year growth rate is expected to decline steadily based on the forecast period as the market becomes more mature. So this is in line with many other previous high-growth technology markets, such as big data or e-commerce platforms. Ultimately, as the number of connections rise, the companies and companies transition to a subscription-based model, IoT platforms are forecast to become a 1.6 billion market by 2021. Okay, so what companies and segments are driving the fast-growing market? Well, there's a number of different players emerging as early leaders. So having invested over 600 million in the past 2 years on strategic acquisitions, PTC is viewed as a leading IoT platform focused on the industrial manufacturing segment. So their ThingWorx platform combines connectivity from Kepware, predictive analytics from Coldlight, augmented reality from Vuforia. So they offer quite an end-to-end solution. And not only that, but they integrate these capabilities with PTC's existing enterprise software business in CAD and PLM. And this enables an evolution into a closed-loop approach that integrates sensor data to improve product design and service. Telit are also viewed as an early leader, and they have a unique position coming from a solid foundation in the connectivity modules business. So their acquisition of Motorola's machine-to-machine business unit and ILS's technologies has turned their focus specifically to IoT. So their ILS's device-wise IoT platform is the basis for Telit's success. Their enablement platform supports application development, again, primarily focused in the industrial IoT segment. They have some key customers like Siemens, or in connected car, they have BMW and Audi. So many companies operating in connectivity, infrastructure as a service, hardware, and enterprise software are, as we said earlier, amending their product portfolio and adding new capabilities like device management, event processing, and edge analytics. So some examples include Amazon AWS IoT, Microsoft Azure IoT Suite, and the SAP HANA IoT platform. So looking at the segments, manufacturing is currently the biggest IoT segment, and it is forecast to remain the biggest opportunity for IoT. So given the cost savings and operational improvements that solutions like predictive maintenance can offer, this allows companies to increase equipment uptime and in turn profitability. Supply chain, smart home, and wearables were the early growth segments for IoT. However, this is expected to level off over time, while segments such as connected health and especially smart city are expected to experience high growth over the next 5 years. So the main reason smart cities are one of the fastest growing segments at 54% is that we're starting to see governments and city authorities making budgets available. And so this allows them to put in place citywide connected solutions that really bring about economic value and potential savings. So this is why they're investing in these citywide programs and initiatives that are not only aimed at enhancing services, but also improving the quality of life for citizens. So an example is in Chicago, $2.6 billion budget was made available for a smart grid initiative to modernize the aging electricity infrastructure. So to date, over 1 million smart meters have already been installed. And by 2018, they aim to have over 4 million smart meters installed. And this is in homes and businesses, and it's aimed at improving reliability, providing better service, and giving customers greater control of their electric bills. So even here in Europe, Barcelona is applying innovative solutions to manage city services and resources. So for example, the city telemanages irrigation with SCADA-based smart water system for the city's parks and green spaces. And that saves them 58 million annually, as well as their parking fee revenues have increased by 50 million annually by utilizing new smart parking technology around the city. So one trend we're seeing is the development of subsegments within verticals based on the use case or the problems that they're trying to solve. So in smart city, for example, we have smart energy supply, smart waste management, or smart transportation, which can even be further segmented to smart traffic lights or smart parking and smart connected mass transit. So this brings me nicely on to part 2 of the webinar, which I'll hand you over to Kevin from Momenta, who will elaborate more on the business aspects and see how the use cases are translating to verticalization of the market from a platform perspective. Okay.
Excellent. Thank you, Patrick. So as Patrick had stated, there are a ton of IoT platforms which have emerged. And what I'd like to do is to take a slightly different view of how this market is formed by looking at the functional areas within an IoT platform, what use cases it meets, and then talk a little bit about how we pivot over and make the business transition to leverage this technology. So hold on a moment while I get the control here. I just need to become a presenter. Okay, and so some of the learnings that I think we get from Patrick's presentation here go a long way toward understanding what the actual market's going to look like. So, hold on a moment. There we go. So as we saw from the presentation, wide variety of platforms. He talked about platforms that were focused like Telit on the actual device management component and how that pulls in the data. Talked about PTC ThingWorx. To tip my cards a little bit, I am a veteran of Exida, a remote monitoring, remote management IoT platform from the old M2M days, and talked about how the PTC application enablement platform is starting to get a lot of traction. And we have seen an awful lot of traction from AWS, I think, as just being a market leader, already having some amount of traction. And also Microsoft is sinking an awful lot of effort into prepackaged IoT services and is sort of the dark horse candidate from the IaaS side. But with all these people claiming that they're an IoT platform, it's a good point to stop and ask what the criteria are for what makes an IoT platform. You know, there's a certain subset of the market which I have am calling sticker IoT, where somebody took an application platform or even just a simple monitoring platform, threw an IoT sticker on it and said, okay, we're IoT, we're going to play too, and we're going to grab a piece of that $1 trillion plus pie that's out there. So when it comes to IoT, it starts with the data, and this has been true for a long time. And when we first started connecting machines, think about a large on-site database like a GHistoria and OSI Pi, where you're collecting massive amounts of data to aid the manufacturing process. We saw this start to grow out into other now portable, now transient relationships where machines are being monitored by portable equipment. If we look at the classic example of an airplane engine, where you're generating 20 terabytes of information per engine hour, massive amounts of data. Now, this can't be inherently an IoT use case because the bandwidth simply doesn't exist. But that source where you're beginning to actually wire up machines and grab data and pull it into a centralized location so that you can perform all those activities that Patrick was talking about, the instrumentation of business rules, the development of applications, visualization leading to analytics. It all starts with the data. And we looked at, when we were back in the PTC days, when we were looking at IoT platforms and partnerships, we came to a conclusion that a certain subset and a large subset are simply these Dido platforms, just data in, data out. Someone has wired up a set of APIs that allow data to flow into a cloud system, and somebody provided a set of APIs so that one can extract data from the cloud system. And this data out, data in, data out functionality certainly got the first use case met, which was to have access to the data in the cloud where you can visualize, where you can instrument, where you can create rules and actions on it. But it's really just the tip of the iceberg. Because once you flow a little bit further downhill from that initial data collection standpoint, you start to see things like firmware over the air being a use case. What if I want to modify that data collection in flight? I have a certain amount, a data collection profile, a certain amount of data being collected at a certain frequency already on the device side. I may want to alter that. I may want to push new firmware to fix a security issue, to alter the frequency with which data is being collected, perhaps to listen to a completely different data source. I may want to distribute content to the edge, which initially sounds like a non-IoT use case. But I've seen this where we've pushed calibration files to medical testing equipment. Content distribution could be advertisements that are displayed in a doctor's office, which was a use case I encountered out of Dreamforce. Coming the other direction, we see a need to take a look at the machines connected to the machine itself. So whether this be a server wherein you have log files being generated from an application and pulled up into something like a Splunk or a Logstash, where they're going to be analyzed so the R&D teams and the maintenance and support teams can take a look. And we also see that data streaming has become huge. If you think of like a Dropcam instance, which I guess is now NestCam, where folks want to get live video, you'll see a little bit in the Davra use case when the demo is shown. The ability to stream data, which is beyond the standard discrete data points of temperature, pressure, speed, those sorts of standard, we'll call them floating point values that come in from the edge. Streaming has become a huge use case, and streaming in both directions. Streaming to get, let's say, video coming off of the device, but also tunneling so that one can access the device, do a screen share session to try to fix something that's happening in the field. Or to provide some sort of voice or video support to somebody in the field when they need assistance. And sort of the foundation of all these, whether or not you went into this IoT stack or IoT platform endeavor thinking you needed device management, you're immediately going to find that you do. In fact, the more successful you are at adding IoT devices to your platform, the more you're going to need device management. You're going to need to figure out how these devices are connected, how to provision and add new devices to your platform, how to manage the security and visibility, which may not just be a simple static, this person can see this device. It may be different devices at different times. It may be shifts where for 8 hours a day, somebody has the ability to access a device, but for 16 hours, you don't want them anywhere near it. You may be governing which parts of your machine can be accessed by a given individual. Take a look at, say, a connected ATM. There are two completely separate machines inside that ATM. One is encrypted, one is not, and you need to govern which side is allowed to have access. So going beyond data collection, there's a ton of use cases that these platforms could choose to endorse. And that, wide coverage of use cases is what has led us to this, of course, gigantic marketing pitch that there's going to be 30 billion devices. I guess, as Patrick was saying, we have throttled back our projections a little bit, or the analyst projections a little bit, to say we'll be somewhere in the 30 billion by 2020. But it's still a gigantic market share. And this opportunity initially led to some irrational exuberance around the possibilities of IoT. And I've seen a lot of this firsthand, whether it happens to be a connected egg crate for your refrigerator, a connected wine bottle, a connected frying pan, connected socks. Not that these are bad ideas inherently, but it's taking this simple monitoring data in, data out technology and applying it to any sort of use case in the world. But the fact of the matter is, just because you can connect something, it doesn't mean it should be connected. And while people are busy doing this, there are some serious opportunities still out there in the field. When you talk about a business case which can be enabled or which can benefit from connected technology. So it was working with a company within our portfolio, and they had a pilot underway with an auto manufacturer in the UK. And they found that not a single piece of the robotic assembly line equipment is actually connected in the IoT sense. Of course, they're connected to PLCs that govern exactly what they pick up, when, where they rotate. All the mechanical stuff had been very well laid out during the programming process, but you couldn't have one robot knowing what happened 2 robots down the line. And you couldn't have an easy roll-up of information that spanned every device on the line. So huge opportunities out there, even in what we would consider to be a high-tech environment. So you don't need to go about connecting socks and frying pans and wine bottles. There are legitimate industrial segments that need to benefit from these use cases. And what's interesting there is that the irrational exuberance was around solving problems based on technology. I have the capability to connect a device, so I should just go ahead and connect everything. But the fact of the matter, most problems are vertical. They're an actual business problem that exists within a business domain, and they need to be solved via technology. So what we've seen with the IoT platform providers is that there's this pretty substantial population which are, I'll be honest, they're going to be somewhat short-lived because they're simple horizontal technology platforms not solving any real business issues, just providing an enabling technology set, which is great if they're open source. But when it comes to actually being successful in the marketplace, it's not going to get you far enough. So what we're seeing is now people are starting to pivot, and IoT platforms are starting to specialize. That's not to say that they can't stretch across verticals. The technology, as we can see, is applicable across basically any vertical, even the sock vertical, perhaps. But what we see is that companies, the successful IoT platform companies, are starting with a vertical go-to-market. Let's go solve an actual problem, a business problem with our technology, and then it becomes an enabler for solving other technology problems. So as a great example, we have Paul Glynn here from Tavra Networks, and they have been a leader in approaching, from a vertical perspective, IoT solutions. So Paul, do you want to take it away?
Yeah, that sounds great, Kevin. Thank you very much. I assume you can all hear me okay. I'm going to share my screen here too. And that should be that. Okay, great. Thank you, Kevin. Much appreciated. As Kevin says, I'm Paul Glynn. I'm CEO at Davra Networks. Given the time constraints today, I probably don't have much opportunity to give you too much detail about who we are, but we're an Irish company based in Dublin, although our commercial headquarters is here in Sunnyvale in California, where I'm based. And we develop a platform for delivering managed services in the area of the Internet of Things. But as Kevin alluded to, we right from the outset believe that IoT was not it's not a horizontal play. Yes, exactly as Kevin has said, it's easy. Data is ones and zeros, no matter whether it's coming from a manufacturing floor robot or a pair of socks or a frying pan. It's ones and zeros. So the type of platform that Porrick alluded to earlier on should technically, and our platform is technically capable of taking data from pretty much anywhere. But the reality is that the Internet of Things will be a service-driven industry. It is about that thing as a service. So we, from day one, have always taken a focus that has been vertically focused and focused on transportation. There are all sorts of reasons why transportation is a key one, but from our perspective, we believe that it was very low-hanging fruit. Transportation is one of the areas similar to manufacturing where there's a lot of siloed solutions there already today. If everybody's familiar with fleet management, driver behavior management, and these type of applications, but they're very, very siloed. You're collecting data from a specific source and you're analyzing, I suppose, and reacting to that data in a very, very specific way. What you're not doing is comparing data from multiple silos, allowing multiple vehicles to communicate with each other, allowing multiple systems within vehicles to communicate with each other. The other big reason for our transportation focus is, even though it is a vertical within the broader IoT space, there are a huge number of sub-verticals and niches within transportation itself. So we work in areas like light rail, heavy rail, we work in mass transit, we work with emergency services customers, so blue light services like police cars, fire engines, ambulances, etc. But we also work, I suppose, in the broader fleet space as well. And one area that sort of crosses over and is like almost a niche within a niche that crosses over between mass transit and fleet is the area of the connected school bus. We have had a number of connected school bus projects through a number of our different partners around the world. But school buses, it's a unique area. It's very niche, very, very focused, and it allowed us to very quickly and easily pick off use cases and business value, and Kevin touched on this earlier on, business value that the client can get from a connected school bus service. Okay, typically and particularly in North America, where there are 500,000 school buses, I believe something like 1/3 of all the school buses in the world are in North America. And there are very specific solutions around things like safety and security, around there's a big federal ruling for reducing all federal fleet vehicles have to reduce their carbon footprint by 15% by 2019. So fuel consumption, vehicle tracking, vehicle management becomes a huge part of that. Then you're into things like employee productivity and student safety. So there are a number of immediate outcomes that we've been able to get in the area of connected school bus, and immediate value we've been able to deliver to our clients that sort of make it a very good use case to show a demonstration around. So for today, I've been asked to show a live demo of our platform. Our platform is called Rubin, Runbook Automation for Networks, which is a throwback to our early days, I suppose, because we are very much a networking company. We understand the connectivity of these assets, and we believe that every project, every IoT project, no matter what it is, starts with connecting the assets. Before you can collect data from them, before you can analyze that data, before you can deal with or react to that data in any way, you actually have to put yourself in the position that you're collecting it and you're getting it back to a central point for analysis. So from our perspective, again, a good place to start is just the connected school bus space. So we have a project. This is a real project with a real customer in Oklahoma, in North America. This view here is sort of a typical top-level view of our platform. You can't go much bigger than the world. So from a scalability perspective, we've designed our platform that we can scale way up to hundreds of thousands, if not millions of devices for each individual customer. Although in the fleet space, believe it or not, most fleets tend to be pretty small. The vast majority of our customers are between 100 and 500 vehicles. You do have customers with 10, 15, 20,000, but that's pretty rare. So although scalability is huge and it's very important in IoT, from an individual customer perspective, we tend to see most of our customers have, as I said, somewhere between 100 and 500 vehicles. These vehicles are represented on the maps by clusters. I can hover over a cluster and then I should get a little pop-up which shows me which shows me the number of vehicles under that cluster. I get a little on the outset here. I get a little sorry guys, 1 second, I just got a message there coming through. Yeah, these clusters represent groups of devices. I can drill down into individual clusters and I see the devices themselves start to break out. Or I can click on my little shortcut here to bring me to an individual vehicle in an individual space. So we are effectively managing, this is a Cisco router, an IoT gateway sitting inside a school bus in Oklahoma. First thing we'll see is we're managing lots and any data we can get from this vehicle. The first piece of data typically is GPS. The schools want to track these vehicles. They can have up to 30 kids at a time on them. So from a safety and security perspective, we want to know where they are. These buses, you'll see that the vehicle is actually moving here. These buses will have a very set route. So the first thing we do is we set a GPS locator, which comes from the router itself, which is a GPS chip, and we geofence it. We create a route, and we want to know if that vehicle goes outside the route. As I hover over the vehicle, you'll see a grayed out area. That is the geofence for this particular vehicle. If that vehicle leaves this geofenced area for any reason, it may not be covered under the fleet insurance because it's outside its route. So we want to know about that. Okay, so that's the use case number one. Nice and simple, nice and easy. Second thing is I can double click. If I click on the device itself, I'll get a breakdown of all the key data that I'm currently collecting from this vehicle. So you can imagine I'm collecting data from vehicle engines, I'm collecting data from sensors on the vehicles, I may be collecting data from cameras on the vehicles. There are lots and lots of data sources here. Our application runs locally on the gateway. It makes a decision, or it allows the customer to make a decision about what data is relevant. What data do we want to collect and deliver back to the cloud service for analysis? What data do we need to react to locally from within the vehicle? And what data is just irrelevant and can be dumped? The certain key data, things like speed, miles per gallon, that type of thing, we can collect and visualize here very simply, very easily. So this is the last 60 minutes worth of traffic, or 60 minutes worth of data from the vehicle engine. We can collect fuel levels, miles per gallon information, key data that the client may want to just observe on an ongoing basis. That's simple, that's easy. All other data, this data as well, and all other data is pulled back into a central database where we can start to analyze it and deal with it over time. But this is the key stuff we want to get a snapshot of immediately. We also, and I think Kevin alluded to this earlier, one of the big things for us is integrating multiple data silos. So we can pull back video data, for example. We can actually pull back, now this isn't live video from the school bus because we're not allowed to stream real video from inside the buses, as you can imagine, because it's for student security and safety reasons. But we can, on demand for the client, actually get real access, immediate access to video data from within the vehicle. And that becomes relevant if, in the case of, for example, we're monitoring the vehicle engine, we're monitoring the driver behavior. If the driver suddenly hits the brakes, we want to know why he hit the brakes, and we want to know what happened inside the school bus at that time. So we correlate that, we collect that data, that snapshot, we show the front-facing video camera to see why he hit the brakes, and we show the in-cab video to show what happened to students when he hit the brakes, and we deliver that as an event back to the school. So by the time the bus gets back to the school, the teacher or the principal or whoever will have on their tablet, they'll have full video evidence of exactly what happened, and they can confront the driver, or they can talk to the driver, talk to the pupils. They can engage because they have a full visibility of what happened around that situation. Also, obviously, as we're collecting data, we are, as I said, we're storing it over time. So we have a concept of GPS replay. So we can look at this route and everything this vehicle did on a historical basis. So where was it today? What was it on the same route yesterday? Same route the day before, the day before. So that allows us to baseline and start to profile the actual vehicle and what it does and where it goes. So if I pick one of these random routes here, hopefully I'll find some red. Yeah, here we go. So here's a lot of red. I'll pick this one here, which probably won't be so as confusing. Hopefully, yeah, here's a little bit more red. So this is a route that the vehicle took earlier today, or yesterday actually. We have a red section here, which means we in some way breached one of the business rules that the client has set. If I click on that, I should get a little pop-up to tell me, oops, there we go. I have to drag along. I can actually get a pop-up to show me why we were red there, so we'll see the incident. And we broke the geofence. So for some reason, the driver drove outside his set route on this track yesterday. That would have been delivered as an event to the principal or to whoever runs the fleet. And when the driver came back in that day, he would have been asked to explain, well, why did you drive outside your route? Could have been something to do with road works. It could have been any issue. But again, it's important information for the school to understand is if their drivers are driving outside routes, they need to know immediately. One of the other big reasons for tracking that type of data is one of the things we profile, and you won't have seen it here because I didn't show it in the pop-up, but we also profile pretty much every piece of data we are collecting from the vehicle. So one of the key pieces is cellular coverage. The reason for putting these connecting these vehicles and collecting this data in the first place initially was to provide Wi-Fi to the students. In this particular case in Oklahoma, some of the students spend up to 4 hours a day on the school bus. But all of the data that's been collected is effectively being collected over the internal Wi-Fi network in the vehicle and sent back over the 4G connection to the outside world. So if we don't have that, if we have a part of our route where we lose access to the vehicle, we need to know about that, because we need to be able to talk to our cellular provider to try and deal with that. But we also need to understand that maybe in the school bus there isn't a lot of critical data, but in other vehicles where we work with clients, it's important that we keep constant contact with that vehicle. So we know we're driving into an area where there's low cellular coverage. We can automatically reconfigure the gateway on the vehicle to flip from maybe an AT&T to a Verizon SIM card. And again, Kevin touched on that earlier on about how you're reacting locally within an asset, how you're actually keeping data within the asset and making decisions on the ground instead of taking it back to your cloud service. That can be pretty critical, and it's very, very important in a lot of our rail park providers, where they may be connecting over cellular, satellite, maybe some form of radio, low power WAN, and keeping a constant connection and constant channel open to the train is absolutely critical. So dynamically from within the vehicle, we can make decisions to how we connect to the outside world. And if we do lose connectivity, we make decisions about how we store the data and then push it back once we've got once we get coverage again. So also, next step, I suppose, is we talk about, well, there's an awful lot of other data being collected that we're not showcasing on the screen here now. One of the big areas, again, for these clients is things like predictive maintenance. So we actually partner, our route to market is through system integrators, and our system integrator partners tend to work with analytics companies. We don't do a huge amount of analytics ourselves, but we can quite happily take data from the vehicles, push it into our partners' analytics systems, let them do their magic, and then they push that output back to us. So this report here, which is quite blank looking because it hasn't been branded for the customer, it's actually a little bit compressed on my screen, but this report here is basically looking at all the vehicles across the fleet and creating baselines across vehicles and actually making decisions about the probability levels of a vehicle having to come in for a service. And if that probability level increases, it goes over 12.5%, we create an event. We automatically bring the vehicle in for a service along with a log of why we believe it needs to be brought in. We feed that into an ERP system, which books in the vehicle for a service. It orders any parts that may be required, and it takes the vehicle off the road. So we automatically integrate with the ERP system that the client has. On a more basic level, and we can do preventative maintenance where we're not doing any analytics, but we look at things like when was this last service, how many days, how many miles has it traveled since, how many engine hours, etc., etc., and we push that data back to the team as well, so they know when to take the vehicle off the road in advance without doing heavy analytics on it. Okay, it's not as a strong service, but it's pretty good without a huge amount of analytics, which can be expensive. Another screen we have here. This is just a sort of an overview of an individual vehicle. We can break down individual journeys where we get average miles per gallon, we get the average route speed, we get any violations. So in this case, there are no violations, but if the driver breaks the speed limit, for example, we can see that, we can drill down, we get the video evidence of where he was when he broke the speed limit. If this is becoming something a driver does all the time in the same space, we may want to drill down into it. Now I'm coming to the end of my time, so I'm going to wrap up, and obviously it's a Q&A session at the end. But just again alluding to one of the points that Kevin made earlier, and actually Bo Porrick alluded to it as well, our platform is designed to be quite horizontal. Okay, we have chosen from a business perspective to focus on transportation, but that has taken us into other areas. One of our partners, for example, started with a project to connect some ambulances, but then when they lost track of the patient, when they left the ambulance, they started to track them into the hospital, and they developed a whole healthcare system about virtual patient observation. We also work with companies like Rockwell on the manufacturing side. So most platforms will have the capacity and the ability to deliver services across multiple areas. But again, we believe that in order to succeed, you really need to focus on one area. And I'm afraid I'm out of time, so I'm going to wrap up now. I'll pass you back over to the guys. Thanks, Kevin.
Okay, so thank you so much, Paul. So you touched on something very interesting there. And once you get a use case, so in this case you happen to do, I'm talking about your ambulance use case. So once you have that, entry point, sorry about that. So once you have that entry point into a solution, your ambulance use case, you folks were from a transportation perspective coming in vertically, monitoring, managing a vertical solution for ambulances that happen to have patients within them. But that created an excellent gateway or an entry point into the setting of the inside of the ambulance. So pivoting from a pure vertical, transportation play, a transportation infrastructure play, or what have you, you've now come into a setting where you're in patient care. Same platform, horizontally applicable, but from a go-to-market standpoint, you came in to the ambulance as a transportation solution, pivoted into patient care within the ambulance, and then once they're hooked on that idea that there's data for the patient within the ambulance, you've got an immediate entry point into the setting of the ER, of potentially even the operating room beyond that when you're talking about the patient care. So IoT sort of pitches this, everything is connected, everything crosses verticals, and that is the goal, and that is sort of the opportunity presented by IoT. But the way that we get there is through an entry point of vertical solutions. We come into a problem vertically. We solve that problem generally within the scope of a project, and that leads to subsequent horizontal opportunity. And that project methodology is something that is worth, I'm not going to spend a lot of time on it right now, but it's definitely worth thinking about. IoT solutions are not simply drop-in solutions. You have your own custom deployed environment. Every environment is different, and every IoT solution I've ever seen has come to fruition through a project. So when you're looking at picking an IoT platform to solve one of your internal business problems or technological problems, what you need to fully anticipate is that there's going to be a project under which you are going to be doing this. And that project may very well take a vertical solution provider, an IoT platform that solved the specific business problem, and then within the scope of the next series of projects, start to spread out horizontally to solve additional business problems. So again, being mindful of the time crunch, what I'd like to do is to hand it over back to Sandra, who has sort of been our facilitator here. So if you want to take it away, and then I believe Tom is going to do the wrap up. So Sandra, have you had a chance to collect up the Q&A from the team? I think, Tom, you may already have a couple questions that have been handed to you. Let's see. Okay, there we go.
I think Thomas found himself muted.
Yeah, Kevin, I have a question for you. What do you see as the top 3 things to look for when selecting an IoT platform?
So I'm going to go with first the maturity and health of the company. We've seen a few IoT platforms, especially in the home automation space, that have not made it and have left people with connected devices that are now connected to nothing. So I would make sure that you're picking a company that's got a fairly healthy profile, some existing customers deployed. I would also say, secondarily, take a look at the edge technology, the data collection technology, to make sure that they either support the types of devices you need, or if you're looking on the server side and you already have that, what the technologies are going to be to pull data in. And I think the third piece would be take somebody who has some degree of vertical expertise based on the industry that you're in, so that you can leverage some of the lessons they've learned with prior customers. That's not hard and fast, but it certainly would make the process a little bit easier. So those would be my top 3 there. Looking at connectivity, a mature company, and then some degree of vertical industry expertise.
Okay, okay. And maybe from an end user perspective, or say an OEM, would you recommend them to really nail the business case first, or before starting pilots or proof of concept?
Yeah, definitely. The if you connect it, they will come mentality doesn't necessarily pan out in the end. And I would say involve all your business stakeholders during your data collection strategy definition when you're trying to figure out how to collect data and what data to collect. Bring the people who are going to consume that data to the table.
Okay, great. And maybe to Paul there. So it's interesting from a platform perspective. What is your way to market really? Is it through system integrators or independent software providers or directly with OEMs?
Yeah, Perk, our route to market, my customer is the system integrator. So as I alluded to in the preamble to my demo, we're network guys. That's our background. And we believe that connecting these assets is always the first phase of a project. So we work with the big vendors like Intel, like Cisco, like Dell, and we go to market through their integrators. So it's a logical extension of the networking industry for those guys. They've been providing managed network services for years and managing sort of carpeted network environments. And now as those networks are extended out to the very edge of the customer's organization, it's just a logical extension. They follow that route and they start to manage those things. So we're finding that connected school bus services, one of our integrators built this service and they've built it and they're selling it to lots of clients now. The healthcare one again came from an integrator who were very involved in that space. They built out a service around connected ambulances, and then they take it into the hospital to an area we could never understand. We didn't have an understanding of what the customer would require, but they did. So that allows us to work with clients in areas that we don't understand very well. Heavy rail is another area that it's hugely complicated and hugely regulated. But by having an integrator who understands the space and can take our platform and build services makes just great sense from our perspective, and allows us to scale globally. Cisco have 53,000 partners around the world. We're on their price list. They OEM us, so any of those partners can now sell our product.
Okay, okay.
So I have a question for you, Patrick. Who would you view as the target audience for the analytics that you folks have done? You've done a lot of research. So are you thinking that this is being fed into end users? What is the target group of people you hope to reach with the good analysis you've done?
Yeah, well, I suppose we're a boutique research firm with a sole focus on IoT. So basically, any IoT decision makers or technical or business decision makers looking to build a connected solution, they first of all need to understand the platform market. So I guess some customers of ours have been OEMs, original design manufacturers, system integrators, independent software vendors. But also we've had inquiries from investment bankers and just general IoT enthusiasts as well. So we do offer targeted market reports horizontally, like on IoT platforms, IoT security, but we also have compiled a list of IoT platforms out there. We're also going to release shortly a use case list, which could be quite useful for any companies trying to understand, say, for example, in the smart city segment, or if they want to look at a specific predictive maintenance solutions across the segments. Yeah, so I think we cover a lot of aspects of IoT for our customers.
Excellent, excellent. All right, so I think given the time constraints here, we should hand off to Tom to do the wrap up.
Kevin, thank you very much. Kevin, Padraig, thank you, Paul, as well. Excellent presentation, really informative. And I want to thank all of the participants. It was well attended. We had well over 100 people on the call, so we're very happy to have such a great audience. And just in closing, while we end the webinar, I wanted to present Momenta Partners as your go-to for executive search, business advisory, and ventures. We have over 24 companies in our portfolio that we've made investments in that we feel very strongly about. We're involved in advisory work, a broad range of connected product companies, and well established as the focused industrial IoT executive search firm. So please, if there's any questions that you have, please reach out to us. We will be following up with all those that registered with the webinar with the information and presentations as they become available. Thank you all very much.
Thanks, Tom.
Thanks, Tom.
Thanks. Bye now.
Thank you everyone for attending today's webinar, The Rise of IoT Platforms. If you have any other question, please drop us a line. You will also receive a follow-up email within the next 24 hours with a link to view a recording of today's webinar. On behalf of IoT Analytics, Davra Networks, and Momenta Partners, as well as our presenters, Kevin, Paul, and Patrick, thank you again for joining us today. Look out for the invite on our next webinar, which will be on IoT security. I wish you all a nice day or evening, depending on where you are. Thanks again for joining us, and bye.